general G is published. And then what next? What can be done next is Alice will select a key. Will select a number. Alice will select a number. I call it x8, which is between 0 and p minus 1. And then Bob will select a number xp, which is between 0 and p minus 1. Okay, so that's a random number. And then after that, Alice will compute y is equal to g to the x thing modulo p. This is, we call it ya. And then Bob will compute yb is equal to g to the xp modulo p. And then after they compute this one, what they will do is they will just publish this one. Okay, they will just publish this. So basically A will publish YA, B will publish YB. So when I wrote the arrow like this, it doesn't mean that A will send the Bob directly, but A will just publish it. Okay, B can also publish it. And after that, what will happen is when A receives YB, then A will do like this. A will compute YB to the power of XA modulo P. This will be equal to G to the XAXP modulo P. This is what I call a key K. On the other hand, Bob can also compute YA to the power of XP modulo P, which is equal to G to the XAXP modulo P. So you can see that these two people, now they can establish exactly the same key, but they have never talked to each other in the real life. They have never met each other. This is actually the invention by Davy and Hammond in 76. You may ask me, what is so special about this? The good thing about this is, consider an enemy here. The enemy will look at this one. The enemy will look at YA and YB. Okay? So the enemy will know YA is equal to G to the XA modulo P. YB is equal to G to the XP modulo P. So the question now is, the enemy needs to come up with key K, which is equal to G to the XAXP. So this one is actually to find K by knowing these two is not possible without solving the discrete logarithm problem. Because if the enemy can solve the discrete logarithm problem, then the enemy can find XA, then the enemy can compute GXP to the power of XA. But without solving the discrete logarithm problem, then this problem is very difficult for the enemy. Okay, so this is actually, you can see that by just using a simple approach like this, Alice and Bob actually can share a common key in which nobody else can do that. Right? And then you may ask me that after this, then what happened? After this, now Alice will have key K and Bob will have key K. Then both of them now can communicate using AES, for example. They use AES. So this key they will use it to develop to build AES. Okay, you understand?